Hi everyone, let's create a probability model with the following example. Computer chips have a 25% chance of being defective. Create a probability distribution for the number of defective chips in a sample of 3. So I'm going to go ahead and write that n is our sample and that equals 3. And then from that, the probability of being defective is 25%. So I'm going to write 0.25. Which means that the probability of not defective would be 0.75. So I'm going to call that Q, which is the same as 1 minus P. And I'm going to write that as 0.75. So the first thing I'm going to do is I'm going to create a tree diagram representing this situation. So I'm going to start somewhere here in the middle and say that 0.25 would be, if I selected a chip, that would mean 0.25 it's defective, and here 0.75 it is not defective. So the first one I pick could either be defective or not defective. So let's call D for defective. And this will be D prime or D complement for not defective. All right, so we are picking 3. So then the second one is, I'm always going to do the defective going up and the not defective going down. So I go ahead and pick another one. And the second one could also be defective, or perhaps it will be not defective. So if you're looking at the tree diagram, that all possible outcomes add up to 1, starting with the first one. So I pick the first one, it's either defective or not defective, that adds up to 1. And then the second one, it's either defective or not defective, this whole outcome adds up to 1. And then we're going to pick a sample of 3. So my third one is going to be defective, or it will be not defective. So these are my outcomes for, if you follow the branches, you'll see there are 1, 2, 3 outcomes. So the first one here means that one possibility is that 0.25, in other words, you pick 3, that will be defective, so 0.25 cubed. And this one here, if I follow along, the first 2 are defective and the third one is not defective. So I'm going to go ahead and write for this one 0.25 squared. And if my pen will just write properly, times 0.75. Remember, for the probabilities, we multiply the branches. So this is 0.75. This is a 2 right here. All right. Continuing along. So we have defective, then we go down, not defective. Then the third one, I always going to put defective on the top. So 0.25, that it will be defective, or it will be not defective here. So following that branch right here, I have, you can see, as I'm following the branches, so for this one, 0.25 times 0.75 times 0.25 means I have 0.25 squared times 0.75. And if I follow this branch, 0.25, 0.75, and then 0.75 here, that means we have 0.25, one of those, times 0.75 squared. Now, if you would like to pause the video and try to do the rest on your own, you could do that and then start it to follow along to see if you get it correct. All right, so I pretty much completed the top one here, all the possible outcomes. Now I'm going to go ahead down here. So the first one could be not defective, but then the second one could be defective. So I'll put 0.25. Or going down here, it could be not defective. So that is a possibility. Let me change the color so it looks a little neater for the eye. All right, so moving along this branch, the first one will be not defective. Then I go up here, it is defective. So always going up is defective, going down, not defective. So this is 0.25. So defective here, or it could be not defective, 0.75. And I'm going to go ahead and multiply across all the branches. So for this one here, okay, I have 0.75 times 0.25 times 0.25. So that means 0.25 squared and then 1.75. 1.75. So I'm writing all my possible outcomes by multiplying the probabilities together. All right, the next one is 0.75 times 0.25 times 0.75. So that one is going to be only 1.25. And then I will have a 0.75 squared because there's 2.75. So I'm going to square this one. All right, and for the last one, we have 0.75, 0.75. Moving up here, the third one could be defective, so that would be 0.25. Or the third one could be not defective, so that would be 0.75. So writing two more of these probabilities, this one right here, you can see that it's 0.75 times 0.75 times 0.25. So again, it is 0.25 times 0.75 squared. I'm always writing my 0.25 first just to keep it organized. And then from here, we can fill in our probability model. And if you look at the last one has 0.75, then 0.75, and then 0.75. That means 3 chips that are not defective, so 0.75 cubed. All right, so here's my tree diagram, and now here's our probability model. So this is D right here represents defective chips, and P of D is the probability of defective chips. So for the first one here, it says, what is the probability you will have 0 defective chips? So when you look at our tree diagram, there is only one option for having 0 defective chips, and that is the last one here. So if you take the first one's 0.75, and then the second will be 0.75, and the third one will be 0.75. There's only one time this happened. So for the probability, I could say there's only one time. We don't really need to put that one, but just to show you that there's only one time where I have no defective chips or 0 defective chips. So I'm going to say 0.75 and raise this to the third power. All right, the next one is asking what is the probability of having 1 defective chip? In other words, only 1.25, and 0.75 squared. So I'm looking for that option. So if we look at our final outcomes here, here is 1 defective and 2 non-defective. And if you look down, there is one more right here. And then a third one below. So it happened in three ways, okay, from all these combinations. There's 3 ways where you can get 1 defective chip. So what I'm going to write here is, first of all, the combination 3, so 3. And then that probability is 0.25. Hopefully I can squish all this in, times 0.75 squared. So I'm not going to put the 0 in. I'm just going to put a 0.75 squared. Okay? All right, let's go on and see the second one, which is having 2 defective. So let's look at our tree diagram and see where are there 2 defective chips. So that would mean I would look for 0.25 squared. So here's 1.25 squared. Here is another 0.25 squared times 0.75. And here is a third one. So again, there are 3 ways that can happen. So I'm going to write 3. Okay, that's a 3. Let me change the color here. Times, in this case, it is 0.25 squared. Times 0.75. So that means there are 2 defective and 1 non-defective. So there's always a total of 3. So you can see if my degree here is 3, my exponent is 3. 0.25, I can raise that to exponent 1. So 1 and 2 is 3. I have 0.75 here. If I put the exponent 1 and 0.25 exponent 2, that's 3. And there's 3 ways that can happen. Now let's look at the last way, which is to have 3 defective. So if you look at our tree diagram, 3 defective would mean the top one right here. Okay, you can follow along and see 0.25 times 0.25 times 0.25. There's only one of those. In other words, there's only one way where you can select all 3 defective chips. So we can say 1 times 0.25 cubed. Now, once we have our probability model, you could see that if you added up all these probabilities, in other words, the probability of 0 defective, 1 defective, 2 defective, 3 defective, you should have an outcome adding up to 1, because all possible outcomes will add up to 1. To answer the next question, it says, what is the probability of having 2 or more defective chips? So that is the same way as asking the probability, if we'll let D represent our defective chips, the probability that D is greater than or equal to 2. So all you need to do is add up the probabilities for, scrolling down here, for 2 and 3, because 2 or more means 2, including 3 as well. So go ahead and enter that into your calculator and see what that would be. What is the probability of having 1 or less defective chips? That would mean that you would enter the probability of D less than or equal to 1. So that means 1 and 0.